All right, hey guys, we're looking at the PowerPoint slideshow for electric circuits. So what we're looking at here is an electric circuit is a closed path through which electrons or electricity flow. Pretty common for you. You probably use one every day if you turn on the light. Or if you plug in your phone using the cord, even with your induction charging whenever you plug into a wireless charging pad. So there's a bunch of different types of circuits and different ways you do it. The main two we're going to talk about that are very basic, kind of start looking at. But we're just talking about a circuit that goes around. It's a closed path through which electrons. So here's a diagram and a picture of a circuit. They say the same thing, just give you a different way of looking at it. So if you're an electrician or trying to look at the wiring diagram of your house, you would see something more similar to what you see here in this picture, right, with a bunch of lines. And this picture represents this little circuit. It's a very simple circuit where you just have a battery, some alligator clips connected to wires, screwed down, and connected to a bulb, which is housing, and then another alligator clip connected to the other side. Here's a positive and negative terminal, and then this light bulb is also known as a resistor. So in this picture, all you see is a resistor. These little squiggle lines mean resistor. This two lines like this, a smaller one and one bigger one, battery or power source. So these other lines are just the connecting wires is all it shows you. So it's just another way of representing the circuit. Here you go. On this slide, you actually see a picture of all the different kinds of diagram. It'd be like I guess it's a key or a legend to a diagram. You've got a battery, you've got a switch, you've got a lamp, a resistor, a voltmeter, an ammeter, or a wire. So last time we saw the lamp or the bulb was a resistor, but it had a circle around it. So that means a lamp resistor. But sometimes you can just see a lamp like this because a lamp is a type of resistor. These are other things we'll talk about later, but it's just a way of seeing and actually identifying what's on a diagram. And here we are getting more specific again. We have certain electrical devices, have the symbols that match, the functions, and something equivalent to them in water. So wire is a straight line, it's a path for electricity flow. It's like the pipes in your house. A battery, positive and a negative terminal. The big line is the positive, small line is the negative. Pushes electricity through the circuit, what gives the energy to the circuit. It's like the pump, in a way. Light bulb, symbol, lights up, obviously, equivalent in water, really. What's a switch? So it's just a little open two dots and a little blended line that goes open or closed. You can tell it's open or closed. Turns electricity on or off. It's like a valve, so you can turn it off, on, or valve. Lets water flow or not flow. A resistor is the squiggle lines. Resist the flow of electricity. It's like resistance restriction in a pipe. What's restriction in a pipe? That could be smaller pipe versus larger pipe. That could be a 90-degree turn. It could be other things as well. So the conducting path produced when the light bulb is connected across the battery's terminals is called a closed circuit. So right here you have a closed circuit on the left because you see that it's all connected here. No breaks in it. Picture's in the way a little bit there, but let me for you. So now you can see that there's no breaks in the circuit. This one, it's open because there's a nice big break right here. The light will not light up. In this case, it will light up. So you have to have a connection from the positive to the negative and no interruptions in between to get a circuit to be closed and for the items, whatever it is, to power up. So with the complete path, there is no charge flow and therefore no current, called an open circuit. Basic types of circuits. So you have a series circuit. Everything goes in line. There's only one pathway for all of the electricity flow. In this case, you have a parallel circuit. So you actually have multiple pathways because they're parallel running to each other to allow electricity to flow. So it can flow down this one, it can flow down this one, and this one. So if one of these goes out or doesn't work anymore, gets broken, there's still a pathway for it to go. So if you can draw a pathway from the beginning to the end, you'd still be able to make it happen. So in this case, you've actually got a switch here in this position here on the parallel circuit. If you were to open this, you would still have a pathway for electricity to flow for this first resistor or lamp here. That would allow this one to stay on while these two would turn off. So information here, series circuit, one path for current. Current the same, voltage may differ, resistance, sum total. So that's just telling you that the current stays the same, voltage is going to differ, resistance is equal to the sum total of all the resistors. In a parallel circuit, there's multiple paths for the current. The current can vary between the different pieces here. The voltage is always going to be the same because that's provided by the power source of the battery. Resistance is the inverse of sum total. So inverse is a word where 1 over the resistance would be the inverse. Resistance just by itself would just be R, just solely R, and then 1 over R would be the inverse. Quantities of a circuit. Voltage pushes electrons, measured in volts. That's the first one here. So that's what you get from the battery. Current flows through circuits. The flow of electrons we call current, which travels through closed circuits. So when those electrons start flowing, you see all these negative charges here. That's the little electrons. That's what's causing your current. Current is measured in amps. So as you can see here, there's a resistance here because it looks like this, because it looks like a little bottleneck because there's less ability for electrons to flow. That's why you have to have bigger wire and smaller wire, because the larger wire can have more room for the electrons to flow, just like in a regular piece of pipe. Current is measured in amps. The abbreviation is amp, or even a big A sometimes can be there. Ohms is resistance, and it can have a different as well, and a couple different symbols. And voltage is a big V. And that's it. So good luck on all the work here, and make sure you get as much done as you can. All right, have fun.